Hello again, friends. So now this is the first video of a little series within a series about JSaddle and working with JavaScript and Reflex. And so the first thing that I think is very necessary to say, if you haven't heard it in my past videos, um, is that there's not actually a lot of cases where we need custom JavaScript. Most of the simple stuff is really handled by Reflex, and it is something that we want to use our like FRP event structure to work with. And as we saw in the last video, which I just filmed a literal second ago, um, something like updating the DOM dynamically can be done by really this code here, which is explained in my last video. And so that eliminates a huge portion of stuff we might need to do with JavaScript. What we might need to do, where I've used JavaScript in the past, is with the WebRTC um, API, and so JavaScript through Reflex. I mean, because I also did talk about the past project which used JavaScript literally for WebRTC, and the reason for that is just because there's no sort of built-in um, functions around it. I have found some in the GHCJS DOM package, but as I had already done it, in just vanilla JavaScript, I kind of said I would rather just basically convert my code um, in the easiest fashion possible. So, it was just easier to do it custom instead of using built-in functions from the GHCJS DOM library. And so that's the thing too, is this video is about JSaddle DOM, but there's a host of libraries to kind of that we could dive into. Um, and so, what is JSaddle? Is the next question. And so JSaddle, as the documentation states, is a library that works with both GHC, JS, and GHC. So what is GHC? We know what GHC hopefully is by this point. Um, what is GHCJS? And so GHCJS is basically something that allows us to convert a subset of Haskell into JavaScript. So I could write any Haskell program that I want, and as long as I don't use certain libraries that just would not simply make sense in a JavaScript context, then I am good to go. For example and a non-example um, is the HTTP client library. So HTTP client is only something that could ever make sense on the back end on a server. You would never be doing Haskell web requests on the client, right? And you might say, well, what about doing JavaScript web requests? And sure, you could do that, but there are libraries specifically for that type of thing. And so if you try to use this kind of library, where we're doing like literal web requests, right? We do parse request, and then I have a built-in function for this, but HTTP LBS pretty much. These aren't. This is effectively what we're doing. There's more arguments that are at play, but this is effectively what we're doing, and making a request and then performing that request. So, it would not be logical to have that kind of functionality on the front end, where JavaScript is used. And now something like if I was to say, if I was to go on HackerRank, do a Fibonacci question, right? Build Fibonacci. Um, then this is something that could convert to JavaScript, because it's just pure code. So there's really no reason why it could not convert to JavaScript. And and like that's an interesting thought because one question that comes to mind for my head is like, could we go the other way? Could JavaScript model Haskell, right? Basically, what we're doing is Haskell is modeling JavaScript. Um, so why can't JavaScript model Haskell? And the reason for this is really just um, you know the guarantees that we have in Haskell make it very easy to relax those constraints. And what do I mean by that? Well, in Haskell we have strongly typed functions, and these are also things that are allowable in JavaScript. Right? We can have a function plus, which goes from some a, where a is of the num. It has an instance of the num type class, and we can put the two together to get uh, a new a, right? 2 plus 7 is 9. Um, quick maths. And so um, this is of course something we can do in JavaScript as well. Um, this is valid, right? You can do 2 plus 7 in JavaScript as well. However, you can also do, as we saw in the last video, 5 plus a. And that doesn't really translate to Haskell. That would be a compiler error. And so, I bring this up to kind of further sell the power of Haskell, um, in that because we are so, you know, restrictive with what types we allow into a function, we build this kind of fortress of reliability in our code, and that fortress of reliability can easily translate to whatever context. And then further we have something like Reflex, where we can model that in an FRP way, and then it's really easy to model whatever the heck. And so the power is just like ridiculous, and exciting. So um, yeah. So I think that's a lot of deliberation for that. And so what are we doing at the end of the day? Well, we could have you know let's take the simplest example possible and pretend that we haven't watched my last video. Haha. uh, so we haven't watched the last video. We don't know that we can use Reflex to do DOM updates. How would we think about how to write this in JavaScript code? And let's call it Reflex JavaScript. We'll just call it for the sake of simplified language. And so what we would do is here's exactly what we would do. We would say get the document by the function, the built-in function, get, I think it's current document unchecked is the actual function. And then we would say document, we have this lens function. And so, well, how would we do this first in JavaScript so I don't scare anyone here? We just say document dot get element by ID. I forget if it's lowercase or uppercase. Some ID dot now we're effectively doing something here. We're gonna say we could say either get the inner text by setting it to a value. We can say x is equal to the inner text, or we can say that inner text is now equal to what's up, dog? And yeah, and so that's what we would do. And now we have this function, and it is a lens you know, and with that said, lenses can be complex. You don't need to know everything about how this lens honestly works. I will get to doing tutorials on lenses. However, they are a massive um, you can get so deep into them, and they are truly powerful, but I don't think they have value in the sense that we need to get people into Haskell to start, let alone trying to find the best way to Haskell and making that the de facto way of doing things. I think it's better to avoid using lenses in your code for the sake of understandable code. Right, readable code is really what matters at the end of the day, and it's also easy to screw them up. But this one is actually quite simple. And so our function here, this is the lens operator, and this is basically just replacing the dot. Right? We'll see. Um, you know, we don't have a function get element by ID, but what we have is I believe it was um, JSG. Let me see here. I actually do this in my code somewhere. Let me find an example. I'll find an example really quick. I'll pause just so I don't show anything I shouldn't. So I found it. And so this is just directly from my code here. So we're going to use the JS1 function, which we'll explain in a second. This is basically just saying it has a name and it takes one argument. And this video ID is going to be, well, just some text. Get element by ID. So I guess it was with a lowercase. And don't necessarily need that. And so we're just going to say the ID is some ID. And now that we've gotten that, we can say the inner text. And what is this again? This would be... So this is using JSaddle. I think it's just... You know what? I gotta pause this again. Oh my. Apologies. So yeah, I was just overthinking it. It's the JS function. So this is the setter. How I figured this out is from the documentation. This is the name of the property defined, and we'll come back to these in a second. And so the property that I want to find is the inner text. This would now get me the inner text, so I could say, as we'll see with the function, was this one? This is going to get me a JS value, which we will come back to in a second. And so must be some text and call it that because that's actually a function. And we could display it in a certain way. But instead, what we're going to do here is we're just going to set it. So we set by using JSS, which is the function here for setting a particular property name. And so this will allow us to do this will take another argument. The inner text is the name, and so now the new value will be what's up, dog. And that's, well, we're doing this not in a real context, but this is effectively what we are doing here. And or rather, sorry, how we would set a value, for a dynamic DOM that we don't want to, or if we did not know that we could already do this with Reflex. But something like this is already handled by the internals of Reflex. And so, anyways, so, if you go to the JSaddle repository under GHCJS, you'll see that there is a tutorial around this. And so once again, JSaddle works with GHCJS or GHC. And further, um, it actually ports to a number of different platforms. So, you know, JSVal War, for example, is actually what's being used here. And so you're running a JavaScript helper on port 3709. Um, and then you can also use it for WebKit GTK. So you can um, create desktop applications, and I'm not sure if it's by Reflex by the workings of Reflex or by the workings of JSaddle, but just as a reminder, we can port to Android or iOS. And so, like, literally every single, maybe not every single case, but I mean, the fact that we can port to a web application, to a desktop application, to Android, to iOS is pretty awesome. And further, we can make sure that the singular code base, which ports to all of these different platforms, is very well typed, and very reliable. And even though it could get infinitely complicated, we can still have the same reliability and error checking that we would have, or that we might experience with any language having a very small minimal application, and that's pretty awesome. So yeah, so now I think what's important to talk about next is that we have this foreign function interface. And so you might be familiar with the foreign function interface for C. There's also one for Java. And here, we can only use this foreign function interface if we are compiling with GHCJS. And so I've done this before. I think currently, I don't know if you can do interactive development, like a interactive REPL with JSaddle. I know that was possible before, and then with one of the most recent releases, they actually took that out, and then now they're trying to put it back in. So it's hard to directly use GHCJS. Um, there's quite a lot of setup, and so that's part of why we're using Obelisk, is because it's quite easy to get going. If you recall the original just sort of project skeleton that we started with, we had the ability to just literally call eval. Which, how do they do that again? You know what? Let me pull that up. Let me just pause this. Pull that up. Actually, I don't need to pause. I can just do this. So this is the actual Obelisk repository. Um, and so what it's doing is just setting you up with the project skeleton at the start, and we had our so we have to use prerender in this case, but we can literally just do eval whatever JavaScript code. And so I believe eval is using, well, yeah, is it GHCJS, DOM? Pretty much everything is directly using the foreign function interface. If you look at the actual code itself, it's just basically, um, you know, like some Haskell function head, and then internally something looking like this. Um, right. So this is effectively saying this is the foreign function interface, which I will admit I do need to learn a bit more about. But here we are creating and naming a function of JS get element by ID, and here's the definition of it. Um, this is kind of special syntax to say that the um, the first argument and second argument, and this is where they go. And so document is the first argument that we'll have, and then some JS string, which is a type created by JSaddle DOM, um, and in a couple places actually, and that will be the argument here. So yeah, and then we get an element as a result. So yeah, this is effectively what we are doing. This is how the internals of the library work, and so it is important to think about, you know, what what platform we're actually working out of. For the sake of Obelisk, when we're doing ob run, we are using JSaddle warp. And so we can even see that you might have seen issues come up before. They're really minimal issues where it'll say JSaddle handler exception, something like that, and that's just because the reason for that is because we haven't refreshed the page and we're trying to communicate with a DOM which has been destroyed, or a server definition which has been destroyed, since we're rapidly developing and switching around. So yeah. A little important, and I guess why that's important to think about, and where was I, is that, you know, when we get into certain functions, these are there are very few of them, but some of these functions can be more expensive depending on the platform that we are using. There's not a huge difference, but it is important to be aware of, and I figured this is kind of the best time to talk about it in our, in our introductory video to JSaddle. And so why they are a little bit more expensive is because these certain commands cannot be lazy in certain conditions. They are synchronous commands. So, if you've watched my video on concurrency, maybe you have an understanding of how powerful, you know, concurrency in Haskell is, and how like ridiculously simple it is to do concurrency in Haskell, and well done concurrency. Like, there's no no training wheels, but very powerful sort of DSL for it, and so the point I'm building to here is that so much of JSaddle is built around concurrency, so that we can model asynchronous JavaScript. Um, there's actually a function run JavaScript which is used, right? It's JSaddle, this actual package, exposes the run JavaScript command, and then all of these use them in their own particular way. And so how that run JavaScript command effectively works is, let's look. Well, you know what? I won't look at it just because it is a little intimidating. But effectively, what it's doing is sending a batch of JavaScript commands to the JavaScript context. So the JavaScript context, in the case of JSVal Warp, would be the actual server which is processing the JavaScript. We can compile now, and you might be wondering, like, why do we want like a JSaddle warp helper? And the answer is simply just speed. GHCJS, takes time because we are compiling, and so when we're trying to do basic or when we're trying to do rapid development, it's a little annoying if every single time we did that. We had to wait a minute or two to see the results of our code. We would rather just have an interpreter and then get going quick. Yeah, and so so that's important to know because there is so much code around JSaddle. There's also GHCJS DOM, which provides a little bit nicer of an interface. Although, like, I don't really use it just because, um, you know, you don't really need a lot of actual custom JavaScript. So for me, the easier thing is just to um, write JavaScript kind of like this, rather than trying to figure out what the appropriate function is. And so all of these, I won't necessarily cover what exactly is happening here because there is a lot going on. I will talk about one function that I now see, but something like append child. I won't talk about because the assumption that I'm going to make is that um, you guys have a bit of knowledge of JavaScript in the background, or at least, maybe you don't, and that's completely fine. But it is important to learn about the actual domain that we are working with, and that being, HTML, JavaScript, CSS, which we are unfortunately constrained to because we are working with the, document object model, the browser, and there's not really a way to get away from, browser JavaScript. We have to use that. Unfortunately, there's no browser at the moment that uses Haskell natively. Um, but that's not a problem because we have GHCJS, which uses template Haskell to compile down to JavaScript. And so that's actually why it's pretty slow, is because of the template Haskell, um, and just because there is simply so much work to do. But we end up with a very beautiful application, a very well structured, type safe JavaScript application, and a lazy one too, actually. Um, so yeah, pretty cool. Um, and yeah, so where were we? Oh, so uh, the last kind of well, no, I'm jumping around a little bit. Apologies. Um, if we're talking something like JSaddle warp, it is important to have something like sync point, and so it may be important to have something like sync point. What this does is it forces all of the unevaluated, lazy JavaScript commands that have been received to evaluate. So, um, you know, uh, if there's some DOM update which the value of the new DOM has never been demanded as input to another function, then that DOM may have not evaluated at that moment. I'm not sure if that's correct, but if there's some maybe a better example that I'm more confident in, because I'm not sure about the DOM aspect, or how that's handled, is that if we have a value, right, some integer, and it has not been demanded by anything yet, then of course it will just be like any other Haskell where it is lazy, and so the sync point forces that lazy execution. It's kind of like using strict annotation, or the bang operator. Um, so yeah, but let's look at this, and there's quite a lot going on here, and we will kind of go back and forth between the code. I will actually do a tutorial myself where I do WebRTC, and I found a fun little thing we can do with WebRTC where we can change the color, um, the like yeah, you change the color of the video feedback, and so we're going to learn how to build a web element um, that displays what our camera is seeing, and how to use media recorder to get the user's media stream, and then directly display it, which is kind of fun. But yeah, so um, you know, so we have a number of these functions, like JS, JSG, JS1, JSS, um, and JS and JSS are kind of, as we saw, paired together in the sense that JS is for getting right, getting that attribute. So body being an attribute, you know, document effectively being an attribute, just because, and this might be a little weird, just because in normal JavaScript we could just simply say, or console. Well, we could say console. Um, we could say document, and these things are directly in scope. But because we're using Haskell, they are not in scope. And so what we would do is we would say, well, JSG document. And this is obviously not going to work because this is JavaScript. It's going, what the heck? Um, so yeah, let me move this over. Um, and so, yeah. So this is just getting the document, and as we saw before, send the inner HTML of that body to being Kia Ora. I'm going to try and run this in a second. I've never actually done this. I've just looked at it a bunch of times. Yeah, that's just kind of how I learn stuff. And so now here, this is a little bit more interesting. We're saying that anywhere on the document gets clicked, we have this Haskell callback, and we'll see that there's a bit of a restriction with this Haskell callback. Let's open this up here. So fun JS call as function. So this is a type we have here. So now it's kind of like JavaScript's a object-oriented language. Haskell's a functional language, and so how do we marry the two? And it really, like, my explanation, my understanding of it, or how I kind of think of it, is that we have this JS call as function, where, you know, basically a object is just a set of attributes and a set of functions. Or even further, if you want to think about it like a Haskell record type, it's a a collection of getters, which where each attribute is a getter of that certain attribute, right? Like if we have, just to be very clear in what I mean, if we had some type data user equals user name is some string, then name would be our getter. And, and so we need to pass, like in JavaScript, we need to pass what that function object is, of course. I guess we would need to do that with Haskell as well. We would need to have some value of the type user, and then like this. That's a little weird. Oh, I guess we don't even use that. I guess I have never actually. So I guess what this is saying, and I've never thought about this until now, to be dead honest, is that this exposes the actual function object to be in scope. And then we have the function arguments, which is really what I usually care about. And so, in JavaScript, we have a lot less constraints around what, around the type safety. So functions can take in variable amounts of arguments, and so we can represent that as being a list of arguments, very simply. And they will all be of the type JSVal. Which we will come back to in just a second for how that actually works in a concurrent context, which we don't need to definitely understand, but it is important to be aware of. And so anyways, we do this JS call as function, and then what we are allowed to do, what this says is that we can do some JSM effects, but we cannot return anything from it, except for I guess apparently JS undefined. Um, and so, um, you know, and this is just a particular way of doing it. Honestly, I'm not really sure why we can't return something from this. That doesn't. This does not mean that we cannot return, values from the JavaScript context into Haskell, and then say like write them to file or whatever, do whatever arbitrary effects. We can, but I don't know why this one cannot do so. Um, yeah. So, but I don't know. I don't know. And so, anyways, but we can still do a lot of effects. We can affect the JavaScript context in any way that we desire. Um, and yeah. So, and really, like, this is just the same as if we were looking at a function that the result was IO unit, right? Instead of JSM unit, IO unit would mean that we can do whatever arbitrary effects in the IO, of the IO type in this monad. So, so that's what we see here is that it is converting. What is this doing? Oh, so JS client X. I guess would just be the same as JS.client. Oh, never mind. Oh, if I have the element. So let's do some document. I guess this would be it. Client X. Or, oh, no, sorry, this is of some click event. So on click, right, on click is some um, event listener, and we can program it so that we can say on click. And now, does this give us the arguments? Oh, it doesn't. JS on click. And so we can do an anonymous function. And so how do we do anonymous functions in JavaScript? Right. I guess we could just do that. And I don't know, I'm just going to say return 5. Just trying to look at the structure more than anything. What? Oh, what the? I guess I could actually just save. Okay, there we go. So we're going to say it's a function, and it's just going to return 5. Cool. So that's effectively what we're doing, and instead of returning 5, we could say, document dot body dot or document dot body equals. I don't know. I'm curious if that works. Whatever. So I guess the JavaScript doesn't work, but it did compile, or get accepted. So, um, and so this is just turning this val into number. And so this is one of the synchronous commands. And let's look at this quick. Val to number. So it's just taking something of the class to JSVal and turning it into a JSM double. And I'm remembering now that we actually forgot to go over the JSVal. So this will take me to it. So this is really anything that can be turned into a JSVal. How are we using it here? I guess we're turning it to double. Why would you want? I don't know. And so the internals of how this works is that is an IO ref with a JS value ref, and so any Haskell values will be, well, okay, so JS value ref is simply an int64, and so any values that are defined in terms of the Haskell context, like if we set let x equals 1 in our do block, it will be, I believe it is of the, it'll be a negative number. So, the value ref might literally be -1. And then the, anything defined in terms of the JavaScript context will be positive values, so that they cannot, destroy each other. And so this can be quite literally anything. It doesn't really make sense to think about. Something that might be nicer to think about is JS string text, which is basically what this is when we would work with it. And this makes sense because everything in JavaScript is basically, at the end of the day, just a string, an untyped string. And it has no ability to sort of do, any type checking here, right? Like I could literally just, I literally just said 1, right? So I can put a function here, I can put a 1 here. And so in that sense, to Haskell is a string, right? This accepts something of the type string. And so that's what we're doing here. I am kind of getting a little bit out of the scope of this introduction here, but I think, yeah. Well, you know what? I think the important parts are really understanding that we have, the ability to get the document, which allows us to do whatever arbitrary logic we do, and then these helper functions like JS1, or JS1. All the way up to, what was it? Yeah, well, JS5, and I think we even have, and just a number of variants of these, right? So JSG is has a namespace. For example, console or document is something that we can just automatically get, right, in this console, or in the entire context. So we can get document, we can get window, and really whatever we want through window is available there. Chrome Cardano's here. What the heck? All right, whatever. So, yeah, and this is literally the entire. Actually, what about this? Can we just say this? Right. So I think it's just the same. Is this the same? Yeah, it looks like it's the same. This is the keyword or the top level reference that will get us the entire state of the JavaScript context. And yeah, so what's this one? I'm kind of actually forgetting about this one. Oh well. Oh, you know what? Okay, so then would be good to go through, is so again, going back to the difference and marrying the two language, um, you know, marrying the two languages together. We have this kind of make args, and we'll just see that this is basically just a um, convenience function. And why that is that we can turn any core value into an arg, something of this type here, right? Something like bool. This will be a single JSVal in the JSM context, but we also have the ability to use tuples to make arguments. And if we wanted, we could easily, very easily make the JS30 function, right? We would just take the tuple definition for the 6 args and turn it into one that's 30 long. We also have the ability to do so with a list, and so really anything of that sort of right? We have lists, we have tuples, and triples, and so forth, and then just plain old values. And so any of these are something that is logically something that can be taken as an argument to a JavaScript function. Um, and yeah, and so that's really it. Well, and these kind of do the same thing. I believe these actually use. It looks like they use this function. Largely this is the easiest one to use for working with properties. Like these two are kind of the most basic for working with setting and getting properties of the JavaScript values. And then we just have a number of other functions that allow us to, do stuff. Um, and these two are just synonyms of each other. Um, and then also, given that we are working with a object-oriented context, we have functions like obj, 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 Odell Beckham Jr., and then we have new, so we can make a new object. And I'm going to pause this video because I actually have a great example of that. Um, yeah, so this is an example of where I used new, and so also just um, a good example of how to keep type sanity with the JavaScript context, because something like a JSVal, right? We can't really enforce any restrictions on it. It has to be allowed to be any string, and so with that said, we don't want to, um, if we're just gonna be what's the word I'm looking for? That I guess type unsafe, then there's not really necessarily a point to using Haskell. We still want to make sure that the values get properly passed around. And so how we can do that is by simple type wrappers, like what I'm doing here. Right, so user media stream and media recorder are just two very simple wrappers. I think this is quite literally a JSVal. You let me pause again so I can grab that. All right. So yeah, this is the definitions that I had for user media stream and the media recorder, um, and it's just simply wrapping this kind of chaotic JS val, because I know, right, I know that it is, when I create it, I know that it is a user media stream. Um, it's a valid user media stream that would work properly in the JavaScript context. All goes well. Um, but I don't want to pass it around as just this plain JSVal because then it has the same type as an int. Um, and that's just yeah, not what we want. Um, so pardon me. Sorry. Um, and so yeah, but now here we're using new and the JSG function for a top level reference, right? I think media recorder is literally a top level reference, although it doesn't make sense. Let me fact check that. I just want to be absolutely sure here. Um, oh yeah, I guess I'm surprised it's a top level reference. Um, Interesting. What? It is? What? Okay. Jeez, I didn't even know that. Yeah, and so now we can just say new media recorder, right? So this would be new media. Oh, do we have to say that? Oh, we need to pass a user media stream. What happens if I go like this? Well, I suppose this will not work. I need to get the user media stream before I can make a media recorder. So that shouldn't actually work. Um, and there is one area where it will throw a type error, but it will never actually shut down the application. Um, and yeah, and that's pretty much it. The last part that I want to talk about is, of course, eval we saw here, but it is basically you can just pass whatever arbitrary JavaScript that you want to eval, and it will work. If we look at the type of eval here, it just allows us to return any JavaScript value. And so this is counter to what we saw with the JS call as function. We can literally pass this value back into the Haskell context, which further reminds me of one other thing that I should definitely mention. And of course, like you will see, this is a massive library. There's a lot going on here. But these are the core pieces that you need to think about, and I would focus on for just getting started with. We'll also have more tutorials, so yeah. So now, what's interesting to note about the fact that we can bring this back into the Haskell context is that any simple function, or sorry, any simple result. So like for JavaScript we could have x, if we have some x. Some of us have many, but if we have some x here, and we say we could set this to being a function, right? Call it f, and we return 5 because 5 is a great number. This is not something that we could pull back into the into the Haskell context. However, if x was simply 1, or x was simply some JSON, will this work? Then we can parse this through asyn, right? The asyn library. And so where was that? If I search here, value. Well, this is kind of it. So I think this actually just has something to do with asyn. I haven't actually seen this before I started preparing for this video, but I know that you can use asyn to convert any effectively JS string to let me find it. Here, let me find it. I'll just take a second to look for it. All right, I may be just tripping. I feel like I saw something quite like this, but directly using asyn. But nonetheless, if we understand asyn, and we look actually at value, and this is from asyn, we can see that this is pretty much just mirroring how asyn works. We can convert very simple JavaScript values to that's doing show JS value, which is actually quite confusing. So we can. This is the core thing here. No. Val to JSON. So this would be a JSON string, which we could then, if this was a more plentiful object, then we could have, if we had set some values to this object, we would see it as a JSON string, which is something we could just convert directly into into Haskell by use of the asyn library. And that will, allow us to do whatever arbitrary sort of callbacks into Haskell that we want to do. And of course, much easier to go from Haskell to JavaScript. All we need to do is just give the value, which has to JSVal. And as you can see, there's quite a lot, such as value, and yeah. And then we can convert it to a JavaScript value. And it's not like we'd want to convert a monad to a JavaScript value because there's no such thing as monads in JavaScript. But all of the core basic values, the core basic types, integer, string, object, are easy to convert to JavaScript. And that is all for this video. There is, of course, more that I could talk about. I could go on and on and on and on and on and on and on. But I don't think it'd be worth it. I don't think it would help anyone. Yeah. So I do encourage you to kind of go through more of the inner workings of JSaddle. There's definitely a lot to talk about, and please do let me know if there's something like let's say there's a very particular thing that you want to see in these upcoming videos. Just let me know. How to work with an API, for example, that we can only use in JavaScript, which is, of course, what we're going to be doing with the WebRTC API. But anything like that, anything that you feel is not covered, just let me know, and I will cover it. Hoping to have an extremely comprehensive tutorial set here. So, yeah. Anyways, happy coding and bon voyage.